Alright, so we're going to start with the volume of a cylinder. We got the formula from the formula chart, which is volume equals big B times H. Remember that big B represents the area of the base, which anytime you have a cylinder, a cone, or a sphere, your base is always going to be that circle. So the area formula for a circle is A, but here we're going to call it big B, is pi r, or radius squared. So that's what we're going to be replacing in for big B. So I'm going to go ahead and rewrite this. Volume equals pi r squared times the height. The h represents the height of the cylinder. Now we need to go ahead and find out what all of the values are and plug it in before we can solve for the volume. I'm going to go ahead and change this radius to red just so I see it. So the first thing we need to do is identify what pi is. Pi is represented by 3.14, so that's what we're going to be replacing into the formula. The radius is always inside of the circle and it only goes halfway across. So this one does give us the radius, so our radius is 3. The height of the cylinder is always going to be between the two circles, or between the top and the bottom. So the height on this example is 4. Now that we've identified all those pieces, we just need to go ahead and plug them in to our formula. So volume equals, instead of pi, we're going to replace it with 3.14 times the radius squared. Do not forget to square it, please. So 3 squared times the height. Remember, it doesn't say times in our formula, but that's what it means when they're touching. Now we're going to go through and use PEMDAS to solve. We do not have any parentheses, so we're not going to do that one. We do have exponents, which is at our radius squared, so we're going to go ahead and work that one out. Please make sure that you rewrite this at every step so you don't lose anything. So we're going to have volume equals 3.14 times, and then we're going to go ahead and do 3 squared. Remember, when you're squaring something, that is the same as doing the number times itself. So 3 times 3 is 9, and that's what we're going to replace in there, times the height still, which is 4. Since we have completed that step, next in PEMDAS is to multiply or divide, and luckily that is going to be our last step, so we can go ahead and multiply all of these together. So we're going to do 3.14 times 9 times 4. When I do this in my calculator, I find that the volume is equal to 113.04. Normally we would go ahead and describe this, but it would be in units cubed because it's in volume, but we're going to leave it as just the value. We are being asked around to the hundredths, which is 2 numbers after the decimal, and that is already 2 numbers after the decimal, so we don't have to do anything here. So we found that our volume is 113.04. Now we're moving on to volume of cones. So I'm going to take that formula chart again and find my formula for the volume of a cone. And this one is a little bit different than the last one. So it says volume equals 1/3 big B times H. Again, the big B represents the area of the base, and with cylinders, cones, and spheres, the base is always referring to the circle. So in other words, big B would represent the area formula for a circle, which is pi r, or radius squared. So I'm going to go ahead and rewrite my volume formula with that in there. So volume equals 1/3 big B, I'm going to replace with pi. I'm going to change my r to the red one again. Radius squared. And then again, to finish that formula, it would be times the height, which I'm going to make in yellow. Now we need to identify all of our pieces in order to plug them in or substitute them in and solve. The first thing I'm going to define is pi. So pi is equal to 3.14, so that's one I'm going to be replacing that with. The next one we're looking for is the radius. If we look over at our image, it gives us the diameter. That line goes all the way across, so we only want half of that value. In order to get that, you need to divide the diameter by 2. So it gives you 15 as the diameter. Divide that by 2, and you get 7.5 as your radius. So that's the number we're going to be replacing r with. The last thing we're looking for is the height, and that is the distance from the bottom of the cone to the tip, and that would be 16 centimeters in this case. Now that we've identified all of those pieces, we're going to go ahead and plug these into our volume formula. So volume equals 1/3 pi, we're going to replace with 3.14. Now again, remind yourself that we are multiplying here for each step, times r squared, so that would be 7.5 squared, times the height, which is 16. Now we're going to go ahead and go through the solving process, again using PEMDAS. So in this example, we do not have any parentheses, so we can go ahead and skip that piece and move on to exponents. Exponents is always going to come to the radius portion, so I'm going to go ahead and rewrite everything just so I don't lose anything. So volume equals 1/3 times 3.14 times, now is where I'm going to actually go through and find what 7.5 squared is. Remember, that's the same as doing 7.5 times 7.5, which gives me 56.25. So we're going to replace that with 56.25. And then do not forget your times the height, which is 16 again. Now we're going to go ahead and we finished all the exponents, so we're going to move on to multiplying. So we're going to multiply 3.14 times 56.25 times 16. That's where we're going to be multiplying everything except for that fraction. So I'm going to go ahead and rewrite this. Volume equals 1/3, and I'm going to multiply 3.14 times 56.25 times 16, and I get 2,826. So our last step here is to multiply the fraction 1/3 times 28 to 2,826. So we finished the main multiplying part. Now it's going into the dividing. That's why I left the dividing part for the fraction. You can multiply by a fraction, but we don't have our fancy calculators like we normally do. So actually what you would do here, instead of multiplying by 1/3, you would actually divide by 3. So technically what we're doing right here is we are taking 2,826 and dividing that by 3 to get the same effect. Now, when I do this in my calculator, I get 942. So my volume for this cone is 942. If we were utilizing the units, it would be centimeters cubed. But since we are not utilizing it when it comes to the Google form, we would just leave it at 942. Make sure you pay attention to the code word that comes right after this.